So, Dr. Yuan, please confirm if you can see my screen now.
Yes.
Okay, that's good. That's good. So, hi everyone. This is Dr. Chaoqiang, and I just joined our department in this June, and just 1 month stayed in CityU. And today I will going to show you the topic on emerging energy utilization for electrical vehicles. I know the time is very limited, so I prepared a lot. I hope it will not be a little bit rushed. So if you want to know more about me, about my research work, our CityU, our department, please go to our website to dig more. I think that will be better. So let me briefly introduce myself with 2 minutes. And in 2008, I spent 7 years in Wuhan University in China to pursue my bachelor degree and also my master degree, both in electrical engineering. And then in 2015, I got to Hong Kong University to pursue my PhD. And after I submit my PhD thesis, I went to Nanyang Technological University in Singapore to do the visiting researcher. After that, I was employed as a postdoc at the University of Cambridge, and I stayed in Cambridge for 2 years. And now I joined this big family in our department, and my research areas mainly focusing on the electrical vehicle technologies and also the electrical machine drives, such like wireless charging and onboard charger or traction inverter or some wireless motor. So here is the outline I want to share with you. I know the content is is a little bit long, but no worries. I will introduce very briefly. And the first one, we should know what and why we need electrical vehicles. And second is the electric drive, and then followed by the wireless EV charger. And also the new breed application of wireless charging is the wireless motor. So of course, everybody knows that the electric vehicles are now very popular, especially for the China government. We are promoting the carbon peak and also the carbon neutrality. So actually, the electrical vehicles can be classified into many types, such like the fuel cell or hybrid or pure battery. This depends on vehicle types, such like we have different propulsion devices, or we have different energy carriers, or we have some different energy sources. But one core is that how to define the electrical vehicles is that at least one of the propulsion device is electrical motor. So the power for these electrical motors can range from very large range, such like several kilowatts, such like electrical bike, and also up to hundreds or thousands of kilowatts, such like the mining truck. And this is some benefits of the EV. So we can say that if regarding the energy efficient, actually we can say the EV can share a little bit higher energy efficiency. And also comparing to the ICE EV, it's the internal combustion engine vehicle. You can say that almost there is nothing emission. We call it nearly zero emission. And also regarding the energy diversity, we can say that the power for the electrical vehicle can, from solar panel or wind energy or oil or anything else, right? Not just the coal or oil. So it will help us to well address the power problem. So first of all, let's come to the traction inverter. Actually, for this traction inverter, we know we need to provide power to the motor to drive your vehicle. So normally we should have the traction inverter, but during the application, normally we should use a parallel silicon carbide or some other IGBT or MOSFET to increase the power rate. So here we have some programs such like the control scheme or imbalanced current or switching loss. So what should we do? Our research group is focusing on the switching scheme to reduce the switching loss. So as you know, when you are driving a car, you cannot operate your car always under the full power operation. Sometimes, most of the time, they are under light loads, right? So the light loads will bring a little bit large switch loss, because now the conduction loss is not the dominant loss. So we need to considering the light load, and we need to improve the switching scheme. So the switching loss for the device, such like the MOSFET or some HDT, the switching loss can be divided into two types. The first one is the current independent, and another one is current independent or current dependent. So the current dependent means during the turn on and turn off processes, the energy will discharged and charged to the parallel capacitance, so it will cause the loss. And the current independent means based on the operation voltage and the current you are operating. So actually will produce some loss during the switching. So we are doing some optimization method to reduce the switching losses, such like this. We just proposed a desynchronizing method for the multiple parallel connected silicon devices. And we just use one commutation inductors to make sure the one half bridge is switched on first and then followed by the other ones. But how can we make sure this happens? To make sure first you open the switch under 0 voltage condition, and the others will be operated at the same condition. So we need to add some commutation inductors to make sure there will be a very tiny, very short-term circulating current loop to help them keep the voltage is 0 among the devices. So of course, this is some very details. And here I just want to show you some of the prototype we are designing, and the power is quite high and can up to 180 kilowatts. And the second part is about the wireless charging. Everybody has a phone, but you need to charge with cable. Of course, for the electrical vehicles, currently, of course, we are using the cable charging, but even when the power is very high, such like hundreds of kilowatt, it's not very safe to human, right? You need to manually operate. So if we have the wireless charger, such like the stationary charge or the dynamic charge, means you are moving and you are charging at the same time. So this is the basic principle, and the inductive power transfer technique is the most popular and most commonly used for the electrical vehicles. And also the power now can reach up to 100 or 200 kilowatt. That's quite high. And also the question we need to address is the safety, because when human being is exposed in the magnetic field, it will have some explosion safety. So we have some standards to make sure the human will not be harmed by the magnetic field. This is one thing we are doing. So normally for the wireless charger, the ferrite is commonly used, but we are doing a new revolution of the material as the magnetic core. So we propose to use a new material such like the nanocrystalline. But nanocrystalline is a metal-based material. It will have very high eddy current when under a high frequency operation. So we need to think about how to address this problem. So we just use some new techniques such like the lamination, and also we can use some flake ribbon, or we can use some powder to improve the system efficiency. So these techniques will help us to further improve the wireless charging system. And this is our result I want to show you. And we are doing a 16 kilowatt prototype, and the system efficiency can reach up to 95%. That's quite high. And also the mechanical, the thermal performance are much more robust than the conventional one. So I talked about the wireless charging and also the motor drive. So can we do something to combine these two? But we call it wireless motor. So previously we have the wireless motor drive, just use the wireless to charge the battery and then use the battery to drive the motor, but it's not a real wireless motor, right? So we need to consider some special cases of the wireless system and also the motor drive system. So we need to combine them and eliminate the inverter or the battery at the motor side. So we create a new breed of the wireless motor. So here is two typical configurations we propose for the switch reluctance motor and also for the bidirectional servo motor. So you can say at the motor side, there is no controller, no battery, no inverter. So all control works and energy conversion work have been done at the primary side. So it will improve the system's robustness. So this is the basic principle, just based on the selective wireless power transfer, and also we do some research work on the magnetic field. And I will go through very quick because the time is, I think it's almost done. And we have done some new topology to address some power balance problem, and also if for motion, for the motor motion, we need to have bidirectional motion. So we propose some self-drive circuits to help them to finish this. So this is our prototype to verify our idea. I think they are working very good now, and we have published some papers on some top journals. That's quite good. So I think that's my story. That's my research story, and all your questions are very welcome. And if you didn't have any question, I can share some moments that I have. Any questions? Okay. So I didn't. Okay, so let me continue. So because I didn't say any questions, so here is some moments I want to share with you. I just want to say CityU is a very, very great place, and as well as Hong Kong, it's a very great place to let you meet some giants all over the world, such like when I was studying in Hong Kong U, I met the president of the National Academy of Engineering in the US. They are quite nice. And also my supervisor, Professor C.C. Chen, and I helped him a lot to do some administration work, such like arrange the interview with some journalists, because he just accepted the visit from our president. And the third one is the Professor Hu Zhenming, that when I was working in Cambridge, we have very good opportunity to meet all giants from all over the world. So it's very good time for you to learn from them, talk to them. And I think CityU is the same. We have a lot of opportunities. We have the global vision to help us to stand higher, to say higher. And I think these opportunities will help you to improve your career, no matter you want to get into the academy or get into the industry. I think that's quite a good idea. And here is another photo I want to show you is that 7 years ago, I was interviewed by the CCTV one, and I'm shown in the Xinwen. I think that's quite interesting and very encourageable moment for me. And I hope they are a little bit helpful for your future research. And you are most welcome, and just join us, join CityU, join Department of EE. So be the next giant. I think you can be that. Yep, thank you. Dr. Yuan, I think you mute yourself, right?
So I just want to say thank you so much, Chaoqiang. I think it is really very good presentation, and you prepared very well. And I think maybe I can ask one more question for the students if the students don't have any further questions. So as far as I know, you are also Hong Kong PFS fellows, right? So yeah, do you have any suggestions for the students to apply for the Hong Kong PFS? So what's the most important thing in your application?
Yes, we all know the Hong Kong PF is quite very competitive. So you must have very strong background, but don't worry, just be active and positive, and be confident just to apply for it and discuss with your supervisor. I mean, the proposed supervisor, just do it. Don't worry too much. If you feel you are qualified to have it, just do it. And once you do that, maybe you have the chance to get to the Hong Kong PF. But if you didn't do that, nothing will pay to you. Yes.
And one more question, because as far as I know, you are very excellent in your master and undergraduate study. So may I know the reason for you to choose Hong Kong instead of US?
Yes, because first of all, the Hong Kong city is a very global city. You know, in Hong Kong, we can connect to the world and also connect to our home base because we are very close to mainland China. And another thing for me is that in Hong Kong, we have a lot of giants with very high reputation in their research area, and it will, if you want to do some research work over the world, you can have a very good opportunity because Hong Kong shares the very high reputation, no matter in the research work and also in the finance or in some very cutting edge technologies, something like that. So Hong Kong is a very good place, and our CityU, of course, our department, I think maybe based on some data, we are ranked at the first position in Hong Kong, so it's quite good.
Yeah, personally speaking, I want to say I could not agree more with Chaoqiang. Actually, we think CityU is a really big one family. We help with each other, and thank you very much, Chaoqiang.